those who can't join tonight can do it later. But tonight we have an awesome presenter, Patrick Mangan. He is the Flathead Reservation agent out of, where are you out of, Patrick?
My office is in Polson, Montana.
In Polson. So he's going to talk about soil, which is so important when we talk about growing any type of plant. So Patrick, I'm going to hand it over to you and thank you everybody for joining. If you want to type your questions in the chat, we can save those for later. If not, then let me know, and I can unmute you, but let's kind of save our questions for the end of it. So go ahead, Patrick.
Great, sounds good. Thank you for inviting me, Rose, and nice to connect with all of you online. So I have a presentation. I'm going to talk a little bit about a lot of different things here, kind of quickly over the course of an hour, but kind of do an establishment of basics about soils in our gardens, some things to think about, and particularly when we talk about gardeners and garden soils, about what we can do to amend a soil. So we'll have some great opportunities to talk a little bit, have some fun, and yeah, always take questions. I'll see here if it'll allow me. There we go. Kind of to move forward. So real quick, just a little bit about who I am. I'm in Polson, Montana as my office, and I grew up in the Missoula area. So we have a small family farm there in just outside of Missoula. We raise cattle and sheep. I also have a small orchard where I raise mostly apples, and I do a lot of vegetable gardening myself, as well as maintain my orchard and my cows and my sheep. So I suppose if the apocalypse ever comes, I can mostly feed myself. Although my garden has to be kind of that, I prescribe to the Charles Darwin survival of the fittest type of gardening environment, where my plants probably ought to take care of themselves, because in the heat of summer, I give them less and less care. I also do some work with ornamentals. I really like pretty flowers and things, but do a lot of growing of food things. So I work on for MSU Extension, just like Rose, I serve the Flathead Reservation communities. So I get to work a lot with tribal communities and tribal enrolled members, and serve them for gardening and agriculture needs. So have a lot of fun over in Northwest Montana. So tonight we're going to talk a little bit about garden plants, what they want, and then we'll talk about the soil that you have. So kind of unpacking what you're starting with, what you can do about that, what you can't do about that. Kind of sometimes you got what you got, and that's what you got. We'll talk about feeding and fertilizing the soil short term, and then also long term, kind of feeding that whole soil community. And then there's a really awesome soil health measurement meter that I want to bring up to you all, and hope that it will get that meter and use it this coming growing season, because it's going to tell you a little bit about your soils that you're gardening in. So that's kind of where we're going. For each of those six pieces, there's some places for me to take some breaks and answer some questions about each of those kind of segments as we talk about them, so that we don't get so lost with soil texture and then move off to fertility and wish that we had asked about what clay does to a soil. So we'll kind of break every so often, allow for some questions. We'll see how that goes. But first off, we'll talk a little bit about what plants want in out of soil, particularly, and what plants need in order to survive and thrive in our garden environments. And if you think about sixth grade science, you probably know most of these that I'm going to kind of show us here. Plants want, sunlight, or could be artificial light, but outside in our garden environments, those plants want access to sunlight. They use that for photosynthesis to create the photosynthetic sugars that they're producing in their leaves and their green tissues. They need water, which they source from soils, and nutrients for growth. And we'll talk a little bit more about some of those nutrients a little bit later, but they get those primarily through the soil system and soil water as well, unless we're doing some very specific foliar applications of nutrients. Gas exchange is something that Plants will do on their own. They will exchange through the leaf surfaces or the stomata of the plants. They'll gather carbon dioxide from the atmosphere and they will release oxygen out of those leaf surfaces through those stoma. But they also want and need the ability for their roots to breathe. So when we talk about soils, particularly and gas exchange, we want soils that have some porosity and some pore space to allow oxygen to infiltrate down into that soil system and to allow carbon dioxide to escape easily. And then some kind of a growing media, which is what soil is for our garden environments. Doesn't always have to be soil. If you've ever gone and explored a hydroponic system, or if you've looked at potting mix for seed starting or some of the mixes that we could buy at a hardware store or a nursery, it doesn't necessarily have to contain soil. It can be a soil-less growing media, but they need something to grow in as plants. So that's what plants want. Why we're talking about soils tonight and why soils are so important for our garden and plant environments is because the soil system and soil ecosystem is a connection point for so many environmental systems and environmental processes that happen for support of plants and support of life. So this is an example for carbon dioxide, where it has that above ground piece, plants goes through plants and goes through animals, but then also goes through soils. Water also has a soil component for its water cycle and that ecological system and cycle. So do nutrients, and pretty much any ecological system that we really want to talk about has a part of that whole system that integrates itself into the soils. So ecologically speaking, soil is super important for our garden environments. If we can enhance and allow for that ease of connection in those ecosystem processes, then we can really promote the health of our plants, because all of those cycles that are supporting our plants have that piece of connection through soils. So part number two, we're going to talk a little bit about soils and what you got. So you got what you got, and whether you like it or not, you might be kind of stuck with it to a certain extent. And we're going to kind of introduce some soil physical characteristics here in this next segment and talk a little bit about what that might mean. And Rose might be able to chip in and help us out a little bit with some of the local soil characteristics there in the Great Falls area. And if you're scattered some other places in Montana, you might glean and pick up just a little bit based on some of the things that we're talking about and what we know about those soils based on our observations. So when we talk about soils, there are 5 soil forming factors that come together at one geographic location over time to combine to make the soil we have. So we start primarily with the parent material, or that geologic material, that rock or geology material that we have that soil forms into. We layer onto that climate, particularly temperature and precipitation, to start breaking down and decomposing and changing that parent material. Topography plays a role as well. If we're in a valley bottom where soils can accumulate over time and soil particles can accumulate over time, then we can have deeper and richer soils that have stayed in place for a long time. But if we're on a slope or a hill, then those soil particles have probably over hundreds and thousands of years, like slowly moved and creeped and eroded downhill with raindrops and some erosion. So we have typically kind of thin soils on hillsides and on hilltops, and deeper, more developed soils kind of in the bottom of a valley or someplace where those soils have accumulated. Plants and animals will have an influence on the development of soil, particularly in Montana. We have a lot of grassland soils. So we have a lot of fibrous root systems in those grasses and those grasslands that will die off and slowly decompose and integrate organic matter into the top layer of those soils as those roots die and decompose. Also, insects and animals can play a role in integrating and developing soils. We have worms and macroinvertebrates, so other insects that'll stir soils and kind of go down in a depth and create different channels and pathways to kind of mix the top couple layers of soils. There can be, particularly in my side of the state, where we have a lot of pine trees, we'll have pine trees that'll drop pine needles that are slightly acidic, and over long periods of times, decades and hundreds of years, they can slowly start acidifying some of those soils. And then time, just the amount of time that that soil and that parent material have been in place and have allowed those other soil forming factors to start activating on that. So the 5 soil forming factors, we'll talk a little bit more about one of them specifically, because it seems like it's the one that we can be most challenged by and we can learn a lot about, and that's the parent material. So that parent material that gave rise to the soil we have, it was some kind of geologic material before it formed soil. So where was it and what was it before it was soil? What was its previous form? Did it arise at that site, or was it moved to that site by a force? So if we have bedrock that was eroded and broken down and decomposed and became soil particles in place, then we call that residuum. But that bedrock would give rise to soils that have a lot of the characteristics of what that bedrock type was. So a sandstone would give rise to a really sandy soil. A shale or a slate would give rise to a kind of clayey soil. I saw a comment there right as we were going that talked a lot about high calcium carbonate and higher pH soils. So there might be some limestone that was part of that parent material mix that gave rise to a soil that has a lot of calcium carbonate in it and kind of a lot of lime in it. And those are all soils that were kind of formed in place from the bedrock. There can also, and Montana's got a lot of examples of places where soil was brought in by some kind of a geologic or geographical force. Water can carry soils, so rivers moving through can carry soils and deposit them over time. I live in the Missoula Valley, which has 3 rivers that come together. So we have a lot of alluvial soils, we call those, that are carried by water and deposited by water. If you think about fast moving water, can carry big rocks and all soil particles, and only the biggest things fall out. When that water slows down, its ability to carry those big particles drops, and so it can drop all the sand out and carry other things away. Really slow moving water would drop out silt and clay. There are places where we have wind-blown soils. If you've ever been to Bozeman, Bozeman is parked right on top of a great wind-blown deposit of soils. Some great silty soils are there. Or if you've ever been to the Palouse region of eastern Washington, those Luss Hills or wind-blown hills are wind-blown soils that have no rocks in them for, in the Palouse, it's, 50 to 100 feet. Imagine the amount of wind that must have to blow to move a rock. But they have great wind deposited soils that are super deep. Also here in my area in Missoula, we have some lake bed sediment soils from glacial Lake Missoula that are kind of remnants and leftover, or even glaciers can push around. Think of a big giant bulldozer moving across the landscape, carrying a bunch of rocks and soil. So that parent material that we get, no matter how it comes from, Rose or your local extension agent can help you use the NRCS Web Soil Survey to learn a little bit more about the parent material of your soil if you're ever interested, and kind of unpack that a little bit more. But that parent material is going to bring a lot of physical characteristics to your soil based on what it is, kind of like I was talking about earlier. If it's a sandstone that turned into sandy soil, then that's going to have a lot of influence over our garden soils. Or if it's a wind-blown soil or a water-carried soil, those are going to influence some of those physical characteristics, which we'll talk about here in the next couple slides. But one thing I need to talk a little bit about before we get too excited about learning all about our parent material is that the realities of our situation, particularly in our human-built environment, is that while we have a parent material for soils that are from that area and represent the geologic material of that area, we may or may not know what happened to that soil and how it was changed, or kind of where it went. So on the left side there we have that picture of a new house construction, and boy, that, like, whatever happened to that soil? It was all torn up, it was flipped over, it was moved out of the site and then brought back, or maybe there was brand new soil from some other place brought in. So it may have a really different set of characteristics and physical properties than what the soil should have based on that information that we have about that parent material. Or if we look at the picture on the right where there's a farmer and a gardener doing a lot of incorporation of organic matter and enriching that soil to get it ready for planting, that might be something that either yourself or a previous landowner has done a lot of work to change the nature of some of those soils. And so while we can learn a lot about our parent material and what that might mean for our physical properties of soil, we may not understand the full history of what has happened there at that soil. So there's things that can catch us off guard for sure. But let's talk about kind of an ideal soil, components of soil, and the proportions of that. So we have a pie chart there in the middle, and this is the classic 6th grade math pie chart. We add it all up together, it equals 100%. There's a couple different pieces of this that I want to talk about. One of the big aha moments for soils is that when we look at soils, half of soils are stuff, the mineral part of soil or organic matter, and half of soils are pore space, open space, some of which stores water. So when we walk around on our soils, when we interact with our soils, it's half stuff. It's half sand, silt, clay, some organic matter, but then it's half pore space and a little bit of water. So if we had solid 100% soil stuff, then we'd have a rock. So it's really important both to have a great balanced soils, and almost every soil really does maintain this balance of 50% stuff and 50% pore space. And we can do a couple things, particularly with some of our clayey soils, to try to maintain this so that we don't compress out that pore space, which is really important for plants, for its ability to hold water and to have that gas exchange at the root zone that we were talking about a little bit earlier. Talk a little bit about one specific part of that, the geologic part, or what we call the mineral fraction, or the inorganic part. It wasn't alive and it's not alive. When we break down that mineral fraction, about 45% or so of our soil system, that mineral fraction, we have 3 particle sizes that we refer to: sand, silt, and clay. Probably terms that we've heard before. Definitely clay soils, sand soils. Y'all have a lot of clay in your area for sure. But that refers to different particle sizes. And you see some measurements there on this slide that talks about how sand is, 2 millimeter diameter in size to 5/100ths of a millimeter. But you can do a lot with your hands and your fingers on your soils to kind of determine a little bit about what types of textures you have. A lot of soils have a combination of all 3 of these. It's very rare to find a really pure sample of just one. But sand, really big particle compared to silt and clay. It feels pretty coarse, like sandpaper, sandy soils on beaches. You can see sand grains individually with your eye as you kind of smear them around on your hand, or if you see them on your floor and stuff. So they're definitely bigger particles compared to the other 2. They feel really coarse. Silt is kind of in the middle. It feels really smooth. It gets a lot smaller. We can't see it with our naked eye. We need some kind of magnification to see individual silt grains. And then clay gets really small as a particle. And as a get a soil particle that's been even kind of disassembled molecularly and reassembled in a different way compared to silt and sand. You can think of silt and sand as kind of little tiny beads of glass mostly. Clay is actually totally different, reassembled. And the sand and silt are kind of little BBs of glass, and clay is more like a brick. It's actually kind of rectangular shaped or columnar shaped. If you were to feel silt and clay, particularly in your fingers, you got a little bit wet, you'd kind of move it around in your fingers, and silt would feel kind of smooth, but it won't feel sticky or tacky quite the same way that clay will. So you can feel it really, smooth. A silt, particularly, you can feel it. It's really smooth. It rolls around really nice on your fingers, but it doesn't stick to your fingers and dry out. As to where clay gets really sticky when you get it wet, particularly. And it's the kind of thing that if you spent 40 or 50 bucks at a spa, you would get that clay mask treatment, that kind of stickiness and dryness. Or if there's been a big rainstorm and you walk across a clayey soil, that's the kind of stuff that really sticks to your boots and just gums up your boots or your tires pretty drastically. So what does all of that mean, those soil textures, mean in our garden beds? So what that means is that based on the predominance of the type of texture that we have in our soils, it'll affect a couple of the ways that our soils behave. Sandy soils, again, really big particle. It's got a lot of big macropores that kind of move around the outside of those soil particles. And it allows a lot of oxygen and water to drain through fairly quickly around the sides of those particles and to infiltrate and drain down into those soils pretty quickly. So it's got great drainage and it's got great aeration and kind of structural support. If you think about a sandy beach, we love sandy beaches because we can go out there, we can watch the waves roll up and wash in, and that water immediately drains deep down into that soil, and we can continue to walk across it. On the other end of that spectrum is a clay soil that doesn't drain quickly, and so will kind of hold that water at the surface for a fairly long time, and it will have that water slowly infiltrate and drain down into it. We love sandy beaches. We don't love clayey beaches like the picture there on the right-hand side. That's not a place where we want to go vacation and hang out at because it would be a miserable experience. Water moves slowly through clay particles. It just moves along all those little tiny surface areas of all those particles and it takes a long time to drain down in. And aeration and that gas exchange in a clayey soil can be something that we want to spend a lot of time thinking about because we want to make sure we maintain as many big air pore spaces as possible to allow those gases to happen. Silt is kind of in the middle. Silt is kind of the Goldilocks of soils. It's an awesome, if you have like a silt loam soil, you're in pretty good shape because it kind of does everything pretty good. Some of the trade-offs with that is that when we talk about sandy soils, it drains really well. It's got great structure and aeration, but it doesn't hold on to water very well. So we can water a sandy soil, but it doesn't store the water very well. It just drains quickly down pretty fast. And sandy soils don't hold on to the nutrients that plants want very well. So we might have to change the way we water and we won't put as much water on there for a sandy soil because it's not going to hold on to it very well. And we might have to shorten the duration or the interval between waterings to fewer days to accommodate that our sandy soils just aren't holding on to water. Clay soils, on the other hand, we can water them and store a lot of water in clayey soils. And we can have more days as our interval between watering because there's more water stored in those soils ready and available for plants. because of the nature of clay and its molecular structure, it has a net negative charge chemically. So it can hold on to a lot of plant nutrients, most of which have a positive chemical charge to them. So it can really hold on to and store nutrients, make them available to enter that plant soil water for plants to take up when we get there. So I can take a break there real quick because I'm going to move on to the next step. Does anyone have any questions that they want to ask about soil textures and soil physical properties? Because we'll kind of head off here and talk a little bit about what to do with those in the next step. So if you have a question, if you can type it into the chat, or if Rose can help you unmute and you can ask it out loud.
I think I got everybody, so if you want to unmute and ask, but if not, like Patrick said, go ahead and throw it in the chat, and even you can throw it in the chat now, and if Patrick moves on, we can ask it later or now.
We can always come back to it at the end. Yep. So I'll give us just a few more seconds. I know that
Can you guys hear me?
yes.
Are you guys going to cover potting soil?
I can at the end, and I can ad lib it just a little bit. I don't have a lot of information about potting soil in my presentation, but I guess I can talk about it just a little bit now. So potting soil and potted environments can be really interesting because they're not like that bulk, large native soil like I just spent a lot of time talking about. When we've in different potting soil mixes, depending on particularly if you're buying it at a nursery or a hardware store or a big box retailer that has some bags, flip it over and take a look at what it says that soil was made from. A lot of potting soils have, maybe they might have a little bit of actual soil in them, but most of them don't have any soil. They're comprised of a lot of them have compost, typically wood fiber based composts. Peat moss is another popular addition to that. And then with those two, compost and peat moss, they can behave a lot like clay. So if we remember the conversation about clay of holds a lot of water, holds a lot of nutrients, really bad at maintaining that air pore space and aeration and that water infiltration, they'll add perlite into that potting soil mix up to 50%, which behaves a lot like the sand aspect to just hold open pore space and allow for aeration and gas exchange and quicker drainage into there. So yeah, and different potting soil mixes, like they're all over the board depending on the company that's making them. A container and a pot is such a it's such an interesting place to grow also because it's a really contained environment. So it'll some of them will have some fertilizer or fertility introduced into the mix as you buy it. And if you have a plant that's a really heavy feeder plant like a tomato, or corn, if you were trying to grow corn in a container, it might pull a lot of those nutrients out within that first growing season or even halfway through that growing season. So yeah, I mean, you can have a lot of the fertility depleted quickly from that enclosed environment. So does that kind of answer your question? Or did you have additional thoughts? All right. I don't hear more. So there's also, so there's potting soil that you'll find like at nurseries and bagged up in different stores. There's also soil amendments, which we will kind of talk about at the end here. So awesome. Well, anybody else have any other questions? All right. Well, I will move on, and if we have questions, we can always loop back to them again. So next part, we're going to talk a little bit about so now we know a little bit about the texture and the type of soil we're facing, whether it's a really sandy soil or kind of a clayey soil. Is there something I can do about that? So let's have a couple conversations, if it'll advance. There we go. And we'll see a couple solutions. One of the first things you can do is you can just kind of become your own citizen scientist, and you can do a do-it-yourself soil percolation test. So if you're gonna, it could be if you're planting a tree or planting some plants, or if you just want to go out in the middle of your lawn, like this picture, and dig a big hole, go out there and do that. And then take a bucket of water and take your cell phone with a timer or a watch or a cup of coffee or whatever you're gonna do. What you could do with this do-it-yourself soil percolation test is to just dig a hole in your soil, fill it full of water, and then observe it and see how fast does that water infiltrate and percolate down into the soil and drain out of that hole. If it moves really fast, then you probably have a lot of sand in your soil, or you have a lot of rocks and coarse fragments in your soil that are facilitating that quick drainage. But if it moves really slow, kind of looks like this picture, it's like, wow, that water's sitting there for a while, several sips of coffee, and it didn't look like it went anywhere, then that might be a sign that you have a clayey soil that's allowing that water to infiltrate and percolate down into it pretty slowly. So that can be one of those kind of take-home messages for yourself. Just how fast does water move through this soil? And how fast do I think air is able to get into the soil to infiltrate? So as we do that, a couple different thoughts for us about things that we can do. So if we have a really clayey soil, clayey, gumbo, sticky, slowly infiltrating, anytime it rains, we just get big puddles, then anything we can do to promote big macro pores or water and air superhighways down into that soil will help open up that soil and will mitigate some of those challenges of working with a clayey soil. Soil, particularly clayey soils want to bond those particles together and make structures or soil colloids. We call them pedons, soil scientists, and kind of wants to glue those particles together and create macropores or bigger spaces in between those soil pedons or soil structures. So we can promote the development of those macropores through a couple different strategies. One of the ways that we can do that is that we can really minimize till or switch to a no-till system. If we think about a rototiller, or if you're more agricultural, a plow, soils will gravitate towards the formation of these structures over time. With roots and organic matter and worms and different things, they'll develop a lot of macropores. They'll develop a lot of air spaces. When we plow or rototill or do any kind of tillage, we kind of push the reset button on that soil. We break apart those soil structures. We kind of pulverize it back to those individual soil grains, and we settle them down, and we can cause some compaction with that. So if you're really forcing and facing challenges with a clayey soil, think about how we can really reduce or minimize or do a no-till system and encourage the development of those macropores and leave them in place as they develop. Let those soil particles glue themselves together. Let those big root channels of plants that we have planted decompose and hollow out the roots, and leave that big root channel in place that goes deep down into that soil, that becomes that water superhighway and that air and oxygen superhighway. Part of that strategy can be to plant some deep rooting plants as well. Could be collard greens, could be tillage radish or daikon radish, we also call it, sunflowers, corn, all of those root pretty deep. So if we grow those plants, we can take off the above ground part of the stuff, but then we leave those big root channels in place. Those become big macropores to move down oxygen and water quickly into that system. Sometimes there's a role for mechanical aeration, particularly if you've seen on turf and lawns. If you've ever seen the little ghost poops in the spring where they've come in and they've done mechanical aeration with those core aerators, that can be an example of in your yard and in your grass environment where they're trying to manufacture and open up some of those pore spaces. Opportunities in gardens as well to do some of that. They make things with spikes on the end of them that you can put into the soil and kind of wiggle it back and forth, and it'll open up some macro pores as well. Compost and organic matter will also promote and break up some of those clayey soils as we can incorporate that into the top couple of inches throughout the kind of the establishment of a good soil for gardening. Those organic matters will allow water to move a little quicker through some of those particles, and then it'll also serve as those organic glues that start gluing those soil particles together. Insects and macroinvertebrates, worms particularly, can do a lot of work. They're going to kind of move up and down through that soil system. They can stir the soil. They can open up macropores as they move through that, and they can open up some big channels as well. And really try to avoid compacting clayey soils because they're pretty prone to compaction, especially when they're wet. So if it's, I know in Missoula here, we probably just got about 1/3 of an inch of rain or so. We got a pretty good rainy day. So on a clayey soil might be a time where definitely I wouldn't want to go out and do a whole lot of garden work today because that soil is pretty wet and saturated. Might give it a couple of days. I wouldn't want to put a lot of pressure on it, run rototiller over the top of it or a lawnmower or something like that. I might let it dry out a little bit because soils that are clayey soils, when they're moist and wet, can compact some of those air pore spaces out of them, particularly when they're moist. If we have a sandy soil, then remember we have great aeration, great drainage. What we need that soil to do a little better job of is to store water and to store nutrients. So with sandier soils, we can incorporate and add compost and organic matter into that soil, which will compost and organic matter do a great job at storing water and storing nutrients. So it really helps to mimic the sandy soils by doing some work with doing the work that sand is not doing in that soil system. We can also really encourage insects and macroinvertebrates to move into that soil as well. And then we may, with a really sandy soil, we might need to think a little bit about how we fertilize and provide nutrients to those plants in that soil. We might need to do a little more frequent fertility treatments with a sandy soil because they're just not hanging on to nutrients as successfully as a soil that's got more organic matter or more clay in it. And as we talked about a little bit earlier, our watering schedule might have a shorter interval because that sandy soil is not storing very much water. So our plants just might need that refreshment of water on a shorter number of days in between those watering cycles when compared to a clayey soil. One other thing we think about when we talk about soils or the soil pH, and somebody typed something in the chat earlier about alkaline soils. So alkaline conditions or a high pH soil. So pH is a 14-point scale. 7 is neutral. Above 7 is alkaline. Below 7 is more acidic. And for acidic soils, the lower the number, the more acidic it is. For alkaline soils, the higher the number, the more alkaline it is. For alkaline conditions, which sounded like Billings was facing a little bit of, and a lot of eastern Montana faces alkaline soil conditions, it can be pretty hard to acidify soils, especially if we've got a lot of calcium carbonate or other salts in that soil, because it's really well buffered chemically against change in pH. There's some places and websites and things that talk about adding elemental sulfur that can decrease the pH, but that can be pretty short-term change. And for some soils, maybe if you're wrestling around an 8.2 or so pH of soil, you can have to add so much elemental sulfur to that soil to bring it back down to 7 or 6.5 pH, kind of where plants are going to be the most happy, that you might wind up with kind of a sulfur toxicity amount because you're going to have to add so much sulfur to it, and it may just not persist, and you might cause some other plant health issues. Peat moss, some people, it is slightly acidic. Adding peat moss, so in a container or in a potting mix, that will create a slight acidic nature to it. Again, with soil in your garden, it can be one of those challenges of, does it do enough? And probably the answer is no. If you're on the other end of the spectrum and you're facing a more acidic soil condition, we face that sometimes here in Western Montana, particularly in soils that are or used to be in and around pine trees. We can add some lime to those soils, and we can bring that pH back up. And there's some references and some information that we have at MSU Extension about the amount of lime that it takes to move move the needle and make a really acidic soil closer to that slightly acidic to neutral type of soil. Saw a picture of or saw that chat that popped up really quickly about adding wood ash to a soil. So you're getting potash or a lot of potassium out of that and a little bit of phosphorus. You can do that in a garden environment, and that would be a way to add potassium and phosphorus. A little bit is going to go a long way with that, in part because there's a lot of other salts, including sodium, in wood ash, and that will so we don't want to accumulate salts in our soils by adding too much. So we want to sprinkle that out really finely across a larger area, and we don't want to overuse that because salt will break apart. It's called a flocculant or a deflocculant, so it'll break apart soil particles and make them kind of single grain again, and it can hold onto water and store water even stronger than plants can get to it. So with too much salt in our soil, we start facing some problems with salts and different salts being in that soil. And if you live in an area where there's a saline sodic problem with agricultural soils, then you might have seen that on the roadside where you have that white crystalline stuff on the sides of the road where plants can't grow because that saline, the saline soils have just accumulated salts to a greater degree. So sparingly over a large area is kind of the answer for that. You might also consider, especially if you're on well water, the implications of the pH of your water and the mineral content of your water as you're adding that water in. Because if you're trying to change the pH on your soil and you're adding kind of alkaline water onto that system, you're undoing something fairly quickly as well. So something for you to think about if you know you face that issue. And this is a great conversation for that, having the right plant in the right place. I have some really challenging soils. I just learned that there might be some things I can change about encouraging macro pores and organic matter, but there's some things I can't change. It's putting the right plant in the right place for the soils and the conditions you have can really help you go a long ways. So there's lots of different resources out there. Gardens and garden centers and nursery centers have some good trained individuals that can help have that kind of pull together and work on that. There can be other growers and mentors in different groups. Master gardeners can help out. Rose or your county extension agent can help out as well. And then there's a lot of great information out there, whether it's a trusted resource or guide, or the seed catalogs and resources, or even I referenced the Missouri Botanical Gardens Plant Finder. I love that website and that resource. There's a piece on that, and it's a little more geared towards ornamentals and perennial plants, but the seed catalogs and resources from some of the companies like Fedco or Burgess Seeds would have similar information where it's going to talk about the types of plants and the types of soils those plants like to grow in. And if you ever see a reference to, like coarse, well-drained soils, then that's a plant that likes a really sandy soil and doesn't like to have its roots particularly wet. Or if it says heavy soils, then that's the type of plant that will tolerate a really clayey soil that's not very well drained. So there's some good language in some of those resources, and you can do some digging, kind of read the tea leaves a little bit and look for some of those language to see what it says about the types of soils that those plants write, and move some of your plant community to the plant community that's going to fit the soils that you have. So with that, I'm going to encourage, so we're going to talk a little bit about fertility. And before we talk about fertility, I'm always going to encourage everybody to do a soil test every so often. Test your soil. Talk to your local extension agent. We can set you up with, a lot of us in our offices have loaner soil probes. We have directions about how to do a soil test, and we have connections with different we have contract labs that we can send that soil sample off to, and they can run a fertility and soil health diagnostic test on it. A lot of them cost, a really good soil health test would cost like $27. And there's really nothing you can add to your soil in your garden for less than $27. So invest that $27 to do that soil sample test. And it's going to tell us some great information about where to go with that fertility treatment and those options that we need. So one of the big things that we're going to learn about in that soil test when we get that report back are the level of macronutrients in that soil for those garden plants that those plants want to use and that comprise most fertilizers. So if you've ever heard of NPK or nitrogen, phosphorus, and potassium, those are the big three nutrients, the macronutrients that plants want quite a bit of, particularly nitrogen. Nitrogen promotes the green leafy growth and shoots for plants to grow and to form all of that green leafy material. Plants integrate a lot of nitrogen into the amino acids that build tissues and structures for plants to grow. So they want a lot of nitrogen every year. The plant form of nitrogen is nitrate, which is negatively charged. And when we talk about particularly clayey soils are also negatively charged chemically. So negative doesn't attract negative. It doesn't hold on to nitrogen very well. But phosphorus and potassium are positively charged, so it'll bond fairly well to soils in a different way that nitrogen won't. Phosphorus promotes some root growth that uses it in some tissue promotion of flowers and the reproductive parts of plants, which are important particularly for our vegetables, and uses it some in metabolic functions. And potassium is really important in those vascular tissues to move water and sugars around the plant and in some metabolic functions as well. So we'll get this information from a soil test telling us where our soils are at as a snapshot, how much nitrogen, phosphorus, potassium, and some of the other nutrients that plants want in our soils. A great time to test your soil is right now in the spring. It takes 10 days to 2 weeks to get that soil test back. So, here in the next couple weeks, our soils are thawed here and ready to go in the Missoula area. Not quite sure where you all are at in your part of the state, but we've had a really warm spring, so things are kind of rocking and rolling already. So I would go out and pull my soil samples now. But if your soil is still a little frozen or still a little cold, you might give it another week or two. Send it off with your extension agent. Takes 10 days, 2 weeks. We still got some time. It's Memorial Day is a ways away, so we've got some time before we need to plant out a bunch of stuff. When we get that information back, we might think a little bit about if we need to feed our soil on the short term. And that's if we get that soil report back and we're not in a happy place. We're not in the Goldilocks zone. We're not, we don't have just the right amount of nitrogen, just the right amount of phosphorus, just the right amount of potassium. We might need to feed our soils this growing season. Excuse me. We might need to test or find from that test that we really need to supply something to our soils now for our plants, because I'm going to plant a bunch of corn, and I know that corn's kind of a heavy feeder, particularly with nitrogen. And gosh, I got my soil report back, and I just don't have a lot of nitrogen in my soils. I might need to feed it shorter term. So a couple different solutions for us to do that. There's fertilizers that are synthetic or chemical based. And we see those bags of fertilizers in the stores a lot of times, garden centers, big box retailers, places like that. They do there's a lot of different configurations of synthetic fertilizers. You can order, like this one says a 10-10-10 right across the front there on the left, where that's referring to the amount of nitrogen, phosphorus, and then potassium, 10% of each. So that's a nice balanced fertilizer. You can find other ones that are maybe a 20-0-0 or a 5-15-5, depending on what nutrient you need to focus on getting into your garden right at the moment for that growing season to feed those plants. You can specify the nutrients, they're tested, they're a little bit monitored. With synthetic fertilizers or the organic fertilizer on the right-hand side, that's derived from organic source. This one is ground up fish parts. They're feeding nutrients to the plants and making it plant available in the soil fairly easily and quickly after you integrate it into your soil. It's not feeding the overall soil system, which we'll talk about next, but it's getting those nutrients to your plants for that growing season. You can also there's a lot of different organic source, like this one's fish fertilizer. There's feather meal from chickens. There's different, bone meal, different things, or blood meal. Different ones have different nutrients. And so you can have a conversation with your extension agent, have a conversation with nursery and growing centers to talk a little bit about what your soil report said and what you're trying to add to the soil and some of the potentials for those. Some organically derived fertilizers don't report the amount of nutrients in the same way that a synthetic fertilizer does. Synthetic fertilizers are actually tested by the State Department of Agriculture. Some of the organically derived ones are a little bit harder to figure out how much fertilizer is actually in there and what form it's in. So I talked about nitrogen and nitrate particularly. In some fertilizers, the form of nitrogen that comes in that fertilizer might not be nitrate, which is the plant available version of it. So it might need to be introduced into the soil and then have soil microbes change that from the version that it is, ammonia or nitrite or something, into that plant available version, which might take just a little bit of time. But let's talk about feeding the soil long term now, which is a strategy where we can talk a little bit about integrating fertility on the long-term scale to feed that whole soil system. So kind of stepping away from, I need nitrogen for my plants this growing season, to how do I support that whole soil ecosystem so that that soil ecosystem can supply nitrogen to those plants year after year. And there's a lot of different things that I can support above and beyond just plant growth for my growing season. Plants and the whole soil system need to be fed. They're a lot like a teenager. And that soil system works together collaboratively as a whole ecosystem to support the soil, the non-living parts, and the living parts, integrating fungi and bacteria and algae and insects all together into some of these soil systems to feed the whole ecological soil system. So when we switch our paradigm or our thought from just giving plants what we need to giving the whole soil ecosystem what it needs to be successful and thrive, we will support our plants and our plant health. In the soil, plants and plant roots work really closely and kind of symbiotically with soil fungi, mycorrhiza, and bacteria to support and feed one another. We used to think that plants had all that above ground leaf surface, and they were photosynthesizing and making sugars out of photosynthesis, and then they were moving them around to different parts of the plants, and then even storing them in the roots. And what soil scientists and biologists are telling us now is that plants will do that. They'll photosynthesize and they'll make sugars and they'll move them down into their root systems, and they'll pump sugars out of their roots into the soil surrounding it, called root exudates. They're feeding the microbes, the fungi and the bacteria in the soil right in close proximity to those roots. So those soil microbes are getting what they need and want, which are photosynthates, the sugars, and they're creating microenvironments around those root spheres where soil nutrients and water are really highly available for those plants, which the plants want. So anything we can do to promote the health of the soil and a strong population of soil fungi and soil bacteria and insects are going to increase the success of our plants, because it's going to have all these great positive benefits with our plants. So we can feed the soil organic matter, particularly to encourage the growth of soil fungi and bacteria, and also insects like worms and centipedes and different insects that want to eat some of that organic matter. Organic matter has a lot of minerals tied up in it. So as the bacteria and the fungi start breaking down that organic matter, decomposing it, they're slowly releasing those nutrients into the soil where plants can take them up through soil water. And then, as we said a little bit earlier, those bacteria and fungi are more or less kind of trading nutrients in soil water for those plant root exudates and metabolites that those plants are producing through photosynthesis. So it's a great partnership that they have going on there. And then insects and worms and things are also eating all that organic matter and eating those pieces, and they're creating those great macro pores through their worm channels and those worm tunnels to do that as well. So feeding the soil with some organic matter will help promote soil health on the long term, and can get us to a place where we can really reduce the amount of chemical fertilizer or those short-term fertility strategies that we need to use, and can help that soil really feed itself and help feed the plants that we're putting in those positions. So a couple thoughts for us about how to do that. We talk a little bit about incorporation into the soil versus soil top dressing. When we're establishing a good garden soil, or when we're working at garden soil, there can be some opportunities to incorporate, particularly shallowly, some organic matters and some things into our soils to help them be in the soil, ready to go, where they can decompose kind of in that top couple of inches and release some of that organic matter into the soil and enrich that soil. But top dressing of composts and mulch can also do a lot of good work to not have it incorporate in, but to top dress it on top and allow it to decompose and to infiltrate and drain down into that soil as those soil ecosystem processes take hold. If you think about the soil surface and then putting mulch on top of it, there's definitely a great interface there where we have a lot of water if we're applying water right there at that surface, or rain is, and then a lot of oxygen in place. So it's going to break down really quickly. We've got all the oxygen we want. We've got a lot of water we want. Things are going to break down fairly quickly and become those root acids and or those organic acids and those slimes that are going to drain down through that soil. And then if you've ever had top mulched your soil and then ever pulled it back, not long after you do it, you start seeing those white fungal mycelia moving through that mulch layer, doing the work to decompose that mulch. And then insects will kind of travel up and down through that mulch, carry stuff down into the soil and kind of mix it for us to do a little bit. So we don't always need to mix organic matter into our soils. We can also do quite a bit of work doing some top dressing, and we don't run into some of those issues that we run into when we bury stuff or integrate it too deeply in an oxygen poor environment. Another thought for us to feed soils over the long term, use of cover crops, particularly in our garden bed environments. Cover crops are typically something that's sown in after we finish up that harvest at the end of that vegetable's lifespan. We pull out our corn, we pull out our cucumbers, pull out our lettuce greens or our chard or whatever. We can plant a cover crop to grow there for the rest of the growing season. We'll have that living root in the soil and that plant that's producing those photosynthates, so it'll continue to push the sugar down in there. And then we get all the benefit of that. This is buckwheat. This is a picture of one of my garden beds, and that's buckwheat that when it gets to a hard frost, it's going to totally kill that buckwheat, and then it becomes a dead plant material that can just fall on top of that soil. It'll start breaking down a little bit, but breaks down pretty rapidly in the spring, and then it becomes all those organic acids draining in. Or you can do a light till to incorporate that organic matter in the next spring. Can also give us, with some cover crops, the opportunity to think a little bit about the targeted cover crops that might do slightly different things for our soil depending on what we want out of it. So tillage radish or daikon radish, it's kind of a carrot-shaped radish. There's a picture of one there on that far right. So if you can grow that, and you can start growing it kind of midsummer into the fall, and that, that radish, I mean, it is a radish. You can harvest it, you can eat it, but you can also just leave it in your soil, let it frost kill. It'll decompose and integrate organic matter into that soil. And behind that decomposition will be a big root channel that is just a macro pore superhighway. Other things like peas or annual clovers are leguminous crops or legumes, so they'll be able to take nitrogen out of the atmosphere and trickle them into the soil. It's not a lot, but it's a little bit. Buckwheat, oats, or rye grow pretty quickly and just get a lot of green mass on top of the soil, cut down weed competition. And annual ryegrass is another one. So all of these will mostly frost kill, and so you won't have to face them in the fall or the next spring, because they'll die in the fall when we get a hard frost. Also, lots of opportunities for some amendments. You can put arborist chips or some wood chips on the surface. Straw or hay can work, or fully composted materials. You could do some inorganics like sand or perlite. Our soil scientist says that you really, like, if you're trying to increase your aeration and your structure of a soil and you want to add sand, you really have to add a lot of sand, more than you think. So you might be pounds and pounds and pounds of sand. So maybe not the best thing, but there are some inorganic opportunities for sure. Peat moss is an opportunity, or if you run across coir, which is the ground up husk of coconuts, it behaves a lot like peat moss, stores a lot of water, stores some nutrients. Some people even use alfalfa pellets, which are pretty high in nitrogen, and are a good source of organic matter. If you use manures, be really careful about manure that is fully composted, and make sure it doesn't have residual herbicides from herbicides that were put onto the hayfield as you treat that hay, or as that farmer treated that hay, because that active herbicide can travel through the hay, through the animal, become an active herbicide in the manure, even through the composting, and then we have an herbicide into our garden beds. So be careful with manures, because once we get contaminated manure into our garden beds, it's a pain to deal with that, and that herbicide will attack our vegetable plants. So it becomes kind of a long-term, a couple of different things. So there's a thing here. If you just type in Google, Montana Extension herbicide contaminated manures, you're going to get a whole report here that would talk about understanding more about herbicide contaminated manures. Also, just a quick plug that not all animals produce the same kind of manure. So a little bit, again, a soil test will tell you what you need. But different types of manures have different levels of nitrogen, phosphorus, and potassium. Nitrogen, plants use a lot of nitrogen. So you might spend a couple of years bringing in a lot of steer manure and feeding your garden. And plants would be really good at scavenging all the nitrogen out of that every year for growth, but maybe not all the phosphorus or potassium. So after a couple of years, we might have really elevated potassium and phosphorus levels in our soils, but not have a lot of nitrogen. And we might need to switch to a different fertility strategy away from manures, because we're accumulating too much of some things and not getting the nitrogen which the plants want. Maybe a couple things to steer away from as well. Again, that herbicide contaminated manures is going to be one of those really important things to kind of avoid. So there's some suggestions in that report about doing a bioassay. If you're unsure, don't put in your garden beds. Do some little samples outside of your garden bed. Try to grow some plants in it. If the plants grow up strong and healthy, then you've done kind of your own little citizen scientist test to see if it'll have action on the plants. They start growing up and twisting and turning and getting manipulated, then you might have that herbicide contamination in there, and that's not something you want to get in your garden bed. We don't want really fine particle materials like sawdust into our garden beds that have got a lot of carbon in them, because the microbes will want to break that down, and they'll look for nitrogen wherever they can get it to help do that breakdown, including stealing it from your plants. Kelp is something that is, kelp and peat moss are kind of lumped together in the same thing of just a question about sustainability. There's a lot of magazines and gardens places that are talking about kelp additions. And if we think about, there's a great picture here of a kelp forest on the continental shelf, and how that's kind of related to the ocean's old growth forest supports a whole ecosystem. If we go in there and cut that down and put it into our garden bed as kelp additions, then we've really clear cut and stripped down that whole ecosystem. And the whole ecosystem that relies on kelp is going to have to move and go someplace else. We've totally replaced that whole community. Similarly with peat moss, the sustainability of harvesting peat bogs can be pretty challenging. So a lot of these things are out there. So there's some questions about, just how sustainable is that ? And then when to do it. A soil test will tell us, in that spring, will tell us if we really need something for this coming growing season. So those short-term fertility strategies might have to happen in the spring and summer. Spring and summer additions of those surface mulches can cut back on some weed pressure, can help moderate some of those swings in daily temperature from hot to cold with that sun exposure, and can also help conserve moisture. So we can layer some of those things on the top in the summers and the spring. And then as we're, kind of changing up beds or flipping beds, or if we're digging out potatoes or carrots or whatever, could be a time in the fall as we kind of do that action to do some light incorporation of organic matters in the fall. Fall can be a great time to add long-term amendments as well, kind of let them sit in place over the winter and continue to go from there. So there's one last thing that I want to talk about really quickly, and then we'll have some time for some questions. I know we're just a few minutes over an hour, so we'll kind of move through and take just a few more minutes. And it's the secret soil health measurement device that you all have access to for a really cheap amount of money, potentially even free. And you can plant it and use it in your garden this spring and summer to do a little measurement for your soil health. And this would be where I'd have a lot of fun with it if we were in person, and we're not. So I'm just going to have to rely on this, which is that you need some tidy whities. And soil health, it turns out, can be measured with tidy whitey underwear. That garden assistant is not available for us for hire, but he is modeling a nice pair of all cotton tidy whitey underwear. You can, if you can steal one from your spouse, or if you have some yourself, then that's a great opportunity for you to put in place some tidy whities. And this is called the Tidy Whitey Soil Challenge, or it's also called the Soil Your Undies Challenge. And if you Google either of those, you will pull up a whole bunch of information about it. It simply goes like this. So get yourself a pair of tidy whities, or clean, not preloaded with any nutrients, 100% cotton underwear. So it has to be 100% cotton minus the elastic waistband, but 100% cotton underwear. Dig a hole down in your soil in your garden about 6 inches, and lay that underwear flat out in the bottom of that hole, and then bury them in that soil 6 inches deep. And then treat that soil in your garden the way that you would for 6 weeks. Treat it the way you would treat your garden plants. Water it, fertilize it, mulch it, whatever you're going to do. Maybe put a stick or a flag or something on it so you remember where they are. And then after 6 weeks, go out there and dig them up gently and pull them out of the hole and see what happened to them. So 100% cotton underwear. So that's kind of the important thing. Cotton is a source of carbon. Carbon is what makes organic matter. So if we have a good, strong microbial, fungal, insecticide community in our soils, in 6 weeks' time, when we treat those underwear as a carbon source that we put in our soil, that microbial community and insect community should start have taken some effort to digest, decompose, and break down those underwear. So I actually did this in my garden. There's my garden right behind these two. Here's the control model on the left there. And then after 6 weeks, this is what I dug up from my garden soil. The microbes and the fungi broke down and started eating and metabolizing a bunch of the carbon out of that soil or out of those underwear. So it left me with a really ratty, holy pair of underwear. If your underwear comes out like a dirty version of the ones there on the left, then there might not be a really strong microbial or fungal community working in that soil. But if they come out like the underwear in the right, then you've got a strong community there feeding on that organic matter as you put it in. So with that, I am done. Here's my email and my phone number. If anybody ever has any questions about soil health, always happy to answer some questions. And I know there were some things that popped up in the chat, so I will stroll through some of those.
We do have one. I can read them off for you.
Okay, sure.
Marissa asked, after a season of growing veggies in a garden bed, what should one do to prepare for the soil for the next season?
So it depends. So I would always, like, at the end of the season, so depending on what you're growing, kind of depending on what you're coming off of, as you're growing vegetables, a lot of times we talk about doing a rotation of different kinds of plants the next year for the next 3 or 4 years. So you might go from like tomatoes or peppers or something that's a really heavy feeder to like peas or beans or something that's a legume and is going to be a really different family of plants that might feed a little bit back into the soil, or greens, spinach and lettuce and chard and kale that are going to be really fibrous and shallow rooted plants. So we're definitely doing that rotation over time. The so soil test is going to help you in that spring, is going to help you a little bit with that understanding of, okay, I had a heavy feeding type of plant, squash, tomatoes, peppers, corn, and I'm going into something else as part of my rotation cycle. What did that heavy feeding crop leave those plants for the next year? And if it's a legume like a pea or a bean, is it going to be able to feed itself a little bit with nitrogen and some of those nutrients, or is it going to need help? So there's that aspect of it. In the fall, after that harvest is done, if you're not facing disease pressures, like if you don't have a disease or an insect or a pest that was really bothering that crop, you can take a lot of that green material that's left over from the plants, you can knock it down onto the soil and you can leave it in place, and that'll be a great covering of the soil to feed it. And then that can also be a great time in the fall to say, okay, I know that I wanted to integrate some composted manures or some different amendments into my soil, so I can put that manure on top, and you can even just top dress it and leave it. Or like we talked about, you could put a cover crop in. So there's a lot of options for you. Kind of depends on what you've grown in that season, how hard you thought it fed, what you're planning for the next season, and then what you think your soil needs and how you want to add it in.
Thank you, Patrick. Another one is, are there any labs in Montana that will test microbial and fungal activity as well?
Yeah, good question. There is, and if you email me, I can email you a list of labs in Montana. There are soil testing labs that do, it's called the Haney test which is you'd spend a little more money for that. But they do a whole kind of soil health and microbial health test on your soil. I'm sure there's some labs that do that in Montana, as well as some contract labs in other places. We would just have to track down a couple labs, and we have a list that we can shoot to you on email that says, here are all the labs doing soil testing in Montana, and then it's just getting on their website sometimes and picking out what tests they offer at that particular lab for the price point. So shoot me an email and I can get you that.
Awesome. Any organic, natural, at-home remedies you suggest? I heard adding banana peels, eggshells, coffee grounds, etc.
Yeah, so those are those are all organic pieces. So the eggshells got a little bit of calcium carbonate in it. Coffee grounds are kind of just straight up organic matter that are really well carbon nitrogen balanced, so they're going to break down and add to the soil really quickly. With any of those, I would really suggest that we compost them fully first. So I'd put them in a compost pile and add some carbon and add moisture and stuff. So maybe if you have a compost system, put those in your compost first. If not, you might consider composting them first and then adding that finished compost into your garden site. If something's not fully composted, then when we put it into our soil ecosystem, especially something that's like banana peels and coffee grounds and vegetable scraps like that, the microbes in the soil are going to take action and try to break that down pretty quickly. On the short term, what that can do is they can take the nutrients that those microbes want for that metabolism out of the soil to do the composting for you, and then release it at the very end after they've composted everything. So if we've composted it first and then put it in, it kind of goes on a really slow breakdown cycle and releases its nutrients, as opposed to the microbes stealing the nutrients from your soil to do the composting in place and taking that away from your plants at the moment. So, but yeah, that's a kitchen scrap compost is a great addition to your soil.
And the last question we have, and if anybody else has any questions, please feel free to put them in the chat. Joe asked, you mentioned acidic soils being present in and around pine trees. Do the pine trees cause acidic soil? And if so, do you recommend planting blueberries around the pine trees?
Yes, but so pine trees and pine needles have a very slight acidifying characteristic as they fall onto the soil surface, and that's over like tens and hundreds of years. Typically where we see a lot of pine trees is also on on more sandy soils, particularly on sandy soils that have developed from like a sandstone based or sandstone based bedrock that broke down and turned into a sandy soil. Sandstone, sandy soils, not very well buffered against pH change. So it's kind of that 1-2 punch of how soils became more acidified around pine trees in a lot of places, but it's not always the case. So first thing I would do is I would test the soil and make sure that the soil test that you choose has a pH test in it. Blueberries want like soil pH 5 or 4.5. They want it pretty acidic. So I would spend the extra time just testing your soil to see what the pH is at that soil at the place you're thinking of planting blueberries. If it is, a pH 5 underneath those trees, awesome. Blueberries are going to want a little more sun is better. So, try to find that place where they're going to get as much sun as possible, but they can kind of tolerate they can tolerate some shade, but they want a little more. So, but test your soil first. Or if you want to ask me about growing hascaps, ask me about growing hascaps.
House caps are amazing. I don't see any comments or questions in the chat. I do want to let the group know that a week from today, on April 11th, we'll have Peter Kolb. He's the Extension Forestry Specialist, and he's going to talk about how to plant trees properly and when to prune. And Danny, hascaps are a cool berry, and probably Patrick, I'll let you describe them a little bit more. They're delicious.
Yeah, absolutely. So they're native to mostly the interior parts of Canada and Siberia, Russia, and parts of Japan. But also there are native hascaps in Montana. They're just super high up, kind of like at tree line, so we don't see them, and they're super small. But there's been some plant breeding programs that have cultivated hascaps, or there's another name for them called honeyberries, and they're kind of a grape-sized blueberry meets raspberry, huckleberry. They've got some tartness to them. Um, they're really resilient plants. They grow really successfully, and they produce a lot per bush, up to 10 pounds a bush, and have a lot of great qualities to them. They're kind of a slightly tangy, tart blueberry. So they're not that super sugar bomb that some blueberries can be, but they have really good taste, work really well in preserves, juices, all sorts of stuff. I'll type in the chat. Yeah, looks like Danny's saying at your nursery, honeyberries, they sell those. If you also look at the Montana Berry Growers Association, and I think it's just montanaberries.org is their website. They've got some information about those as well. And if you want to email me, oh, I spelled Montana wrong. If you want to email me on my email there, I can get you a whole bunch of information about hascaps. They're super awesome. I work with the berry growers quite a bit, so I know a lot about the berries, and we can hook you up with some information on them. So.
Awesome. Well, I want to thank you so much, Patrick, for spending time with us and presenting. I learned a lot of stuff tonight as well. So, soil is so cool, and it's just kind of the basis of everything that you grow. So, if anybody has any questions, you can email me or you can contact Patrick. But I just want to thank you so much for spending your evening with us, and have a great time.
Yeah, everybody have a great night.
And it's good to see you, Peggy.
Oh yeah, bye, Peggy.
Awesome. All right, we'll see you next week. Thanks, Patrick. Have a good night.
Thank you, Rose. Yeah, you all have a good night as well. Good night.
And Maelstrom, I will put this up on YouTube, and I will send out the link to you guys tomorrow. So for those who didn't make it tonight, we'll have a recorded link. So, and I'll send it to you too as Patrick. So
Thank you.
good night, everyone.